complete the VIRP analysis for a combination circuit that has 3 resistors. As you can see, I have 2 resistors, the 10 ohm and the 20 ohm, connected as a parallel unit, and I'm designating the unit AB. And AB is connected in series with the 30 ohm resistor. So we have a parallel part, the AB, and the AB is in series with the 30 ohm resistor. So if we were to redraw this, this is what it would look like. Instead of the parallel, I would have the equivalent. We'll call this RAB, and that would be connected to our 30 ohm resistor. So that's another way of viewing this. Okay, so RAB is in series with the 30 ohm resistor. So let's set up our chart. So we have V, I, R, and what I'm going to do is I'm going to ignore P this time. It's not really important for us to calculate power. We know power is just the product of I times V. I'm more interested in showing you how to analyze everything else. So we have R1, R2, and so let's go back up here. That's R1, and this is R2, and this would be R3. Now I mentioned that we have R1 and R2. R1 and 2 form what we're going to call RAB. That's the combination, the parallel combination. And then finally we have R3 and RT. So set up our chart, because that's going to help us organize all of our numbers. And it also is going to help us decide in what order to do the calculations. Now, as I did this problem earlier, and I think I came up with 9 distinct calculations that I have to do. I know that sounds like a lot, but they're all small little calculations. So let's put down the given information. What do we know? Well, we know that R1 is 10 ohms, so let's put a 10 there. R2 is 20 ohms. We don't know what RAB is, not yet. I'll show you how to figure that out. R3 is 30 ohms, and we don't know the total resistance. I'll show you how to do that. We know that the total voltage is 4.5 volts. And it looks like that's all the given information. So all those other boxes we have to fill in. And we're going to have to do this step by step. So the question is, well, let me just make a little note again. Let me do this in red right here. There's some space. R AB is in series with R3. Okay. RAB is also called the equivalent resistance of R1 and R2. In other words, what I could do is I could replace R1 and R2 with the equivalent resistance, which we still have to calculate. Let me also make another note, very important. Always reduce parallel sections to equivalent resistances first. Okay, so that's what I did here. And that's going to simplify our calculations. So calculation 1. I guess what we should do is we should figure out what is the resistance AB. So let's write that down. Step 1. What is RAB? Okay. So since I know R1 and R2 are in parallel with one another, I need to use the parallel rule. So that would be the equivalent, 1 over the equivalent resistance, 1 over RAB, is equal to 1 over R1 plus 1 over R2. R1 and R2 are in parallel. So if I want to know the total resistance, I need to use that formula. So 1 over RAB is equal to 1 over 10 plus 1 over 20. So 1 over RAB is equal to 0.100 plus 0.0500, and that is 1 over RAB is equal to 0.150. And if I take the reciprocal of both sides, so I flip both sides, RAB is going to be equal to 1 over 0.150, which calculates to 6.67 ohms. Right there. So there's our first calculation. Let's put this in a box. Okay, we're done. Well, we're done with RAB. So let's write that number into our table. RAB, where's RAB? That would be right here, 6.67 ohms. So we have one of our answers. Good. So let's do our second one. Let's do it right here. I'm going to number these so you recognize the order that I'm following. So what's the next thing that I can do? Well, since I know that RAB right here is in series with the 30 ohm resistor, I know that the total voltage, sorry, the total resistance, that's what I meant to say, is equal to, let me think about this. I can add those two resistors to figure out the total resistance. So RT is equal to RAB plus R3, because those two are in series with one another. Okay, look at that yellow circle. Okay, those two are in series. So RT is equal to 6.67 plus 30. So RT is equal to 36.67 ohms. Oh, of course it did that in yellow, I just noticed that. Sorry, I'm looking down at the paper and I glance up at the screen once in a while. So I'll switch back to a normal color. Okay, so RT, this is in the table 36.67 right there. Okay, so what's the next step? Well, as I see it, I would figure out what the total, let's go back to the table. Okay, right here, see that? So go back to the table and I can figure out what IT is now. Okay, so let's figure out IT. That'll be our third step. So I know that VT is equal to IT RT. VT is 4.5 volts. IT unknown. RT is 36.67. So IT is equal to 4.5 divided by 36.67. So that's equal to 0.123 amps. So I have another piece of our puzzle. Okay, so let's write that down. 0.123. And there's an amp. A for amps. Cool. Okay. So since I know what the total current is, let's go back to the diagram here. I'm going to add something. Okay, let's pick what color? I'll do green. Okay, so I know that the current that goes here, let's call that I, is going to be the same through the 30 ohm resistor. So back to the table. That's the 30 ohm resistor, 0.123. And I know that the current through the 30 is going to be the same as the current through RAB. So back to the table, 0.123 amps. Okay, so I should write that down. Let's do that as a step 4. I know that IT is equal to I3, which is equal to IAB. And because of series rule, okay, 3 and resistor 3 and equivalent resistance AB are in series with one another. Okay, so moving along, step 5. That sounds like we're halfway through. Step 5, what could I figure out now? Well, if you go back to the table, you can see that I should be able to figure out those two guys there. So let's do R3 now. So V3 is equal to I3R3. V3 is equal to 0.123 times 30. So V3 works out to 3.69 volts. Oh, I did it again, yellow. Too bad you can't yell at me while I do this. Okay, so 3.69 volts. Okay, I'm using my black pen, I hear you. Okay, 6. Let's figure out what voltage of AB is. That's IAB times RAB. So VAB is equal to 0.123 from the table times RAB from the table. So VAB is equal to, plug it into the calculator, and what do I get? Sorry, the calculator's misbehaving. Okay, 0.820 volts. Okay, good. So this is 0.820 volts. Oops, wrong spot. Okay. So what do we say? 0.820 volts right there. And now what? What's the next thing I should do? Volts AB. How about, oh, I know. So since I know what the volts, let's go back to the first diagram. Okay, so let's look over here. So since I know the voltage between point A and point B, R1 has the same voltage as R2. We know that because that's the parallel rule. So I guess that means we can just fill out the table with this is 0.820 and this is 0.820 volts. So let's write that down. So 7, I know that the voltage between AB is equivalent to the voltage 1, which is equivalent to voltage 2. Okay, so that's just a rule. Okay, so we're almost done. So step 8, remember I said there were 9 steps. So step 8, we want to figure out I1. So V1 is equal to I1 R1. V1, we just calculated, 0.820 is equal to I1 times 10. So I1 is going to be equal to 0.0820 amps. Okay, so that's 0.0820 amps. And last step, V2 is equal to I2 R2. V2 0.820 is equal to I2 times 20. So I2 is equal to 0.0410 amps. And finally, 0.0410 amps. I'm done.